Welcome to this SYSGO TechCast, everybody. My name is Joe Richmond Knight, Field Applications Engineer for SYSGO. I'm joined today by my colleague Stanislav.
Yeah, hi Joe. Thank you very much. My name is Stanislav Schulz and I'm a Field Application Engineer by SYSGO since last year, and I'm happy to be here today.
Thank you, Stanislav. Great to have you. So, we're currently working on a number of eVTOL projects, as you know, with a number of our customers, focusing primarily on the transformation of metropolitan transport. But given your understanding of the capabilities of these platforms, how do you think such eVTOL platforms could be applied to the agriculture industry, for example?
Yeah, it's quite an exciting topic right now, and it's also really hype on the market. The eVTOL technologies seems to be a future of us all around the world, from the small cities up to the bigger metropolises. But for the first, we have to understand what is actually the eVTOL. So this is electric vehicle takeoff and landing machine, which typically has several electromotors with propellers, which giving you the ability to take off and land and at any location, even on unprepared field. And this possibility giving you a great advantage compared to classic means of transportation like airplanes or helicopters. And these machines, the eVTOLs, right now speeding up its development. They have a vast amount of money investments since last years. And of course, it's also going to influence the agriculture market because it's giving you the additional possibility of transporting the larger goods and larger fertilizer, for example. At the moment, the farmers already all around the world, from US to China and also in Europe, using smaller drones, like smaller UAVs, to do the observation of the fields, spread some chemicals, and doing some analysis like field mapping and surveying. They also do crop monitoring and health assessment with different sensors. For example, they apply multispectral cameras, which giving you the possibility to see the health data status of your plants or crops, or you can see where the watering is working fine or not really. And all this you can do already with the smaller drones. But also you can do the yield prediction and optimization. Some bigger drones can carry up to 10 kilograms right now, some of them even 20 kilograms, and they can use it for seed sowing, or with nice cameras, you can also do even livestock management. And there is even software already being developed based on AI, which can give the farmers possibility to do the counting of the sheep underground, and it's really helping to optimize the time. On the one side, we have the eVTOLs, which are quite big, and on the other side, we have small copters, which are already being in use. But we have a number of challenges for this technology to be widely spread. It's like regulations, privacy concerns, technical limitation, noise, especially noise. It's one of the big concerns right now to use the eVTOLs quite wide.
I suppose the concept of vertical takeoff and landing is nothing new. However, the introduction of electric propulsion creates a new challenge in the domain of safety and security.
Yes, you're absolutely right. So safety and security is the biggest challenge for society to accept this new technology, because the propulsion engine has been already on the market since like hundreds of years in some cases. And we already went through all possible safety certification and safety standards. We developed procedures where we can be sure if the engine or the system meet these requirements, we can safely fly around the big cities or a large amount of people, and it's going to be safe. With the new technology, with eVTOLs, it has its own advantages and disadvantages. So from one side, it's a new technology, so nobody knows how it's going to behave. And some safety standards right now are being developed. Even Federal Aerospace Agency in US also saying that we don't have the 100% sure legal base for doing a certification for eVTOLs, but it's being developed. And And at the end of the day, the eVTOLs, from one side, as I said, it's a new technology. From the other side, comparing, for example, to helicopters, the helicopters has just one motor and one propeller, which is carrying the whole machine. And if it fails, the whole system will fail. On the eVTOLs, we have most of the time more than 4 or 6 propellers. And if one of them fails, nobody gonna die. So the machine have a big chance to land safely without any issues. So, and this is a big advantage of the eVTOLs from my point of view.
Okay, interesting. Thank you for your insight. How, in your opinion, how do you see this market transforming over the next 10 to 20 years?
So from my point of view, we will see this barrier which we have to overcome in terms of safety. That's why I strongly believe that the new eVTOL technologies will be applied in agriculture sector first, because there is much less concern when in terms of safety when you fly around the fields or around the forest, for example. If it's crashed, then nobody gonna be hurt. But in this way, the people will learn this technology, will learn to trust this new technology. And in the meanwhile, we will develop the certification procedure to ensure the safety. And through this process of using this technology in agriculture, we gain two main advantages. From one side, we learn this technology, increase safety, and gain the trust of the people. And on the other side, we're giving the possibility for the farmers to be more flexible, use less resources on servicing, because servicing electromotors is always easier than servicing in a standard combustion motor technology. And they will have a possibility to transport like larger sensors, more fertilizer, and doing much more stuff for effective agriculture process.
Okay. So I suppose one of the biggest challenges that this industry or this technology needs to overcome is the adoption and the trust in such a new technology, one that's being rapidly developed and as you say, are still being modified for this new use case. If we focus on the technical challenges of such a technology, the electric propulsion of vertical takeoff and landing, do you have any thoughts or theories about what those challenges may be and how the industry is currently aiming to overcome those?
Yes, definitely. So from my point of view, we will see like the test period within the next test years, the test period of technology, the test period of society acceptance. And from the technology point of view, of course, we always have to consider that every flying machine has a big consideration of weight. And the weight comes from the applied technologies like batteries, motors, electronics. And of course, we have to consider every single gram of weight which we use for flying this machine. And that's why it's going to be very important to save as much hardware as we can. And here we can see the technologies which comes into game, like using heterogeneous systems. So this is a big SOX, which is like a big chip, which is including several chips inside themselves, doing different jobs like controlling the engines, controlling the batteries, controlling the cockpit, navigation, and many other stuff, everything on one chip. But to be able to provide a certain level of safety, these tasks have to be separated and run independently from each other. So if something is failed, the whole system won't go down. And here we see the application and the great usage of a hypervisor-based operating system like PikeOS, which is giving the possibility to handle first a multi-core system. It also giving the possibility to separate the functionality of different islands of these heterogeneous systems. And of course, if you have this possibility to run everything in parallel and with a strict separation, we can save an additional hardware, where we at the end of the day saving also the weight. And this is a great advantage of such systems towards the highest safety standards, especially in avionics, like DO 178, which may help to overcome this problem, this challenge with safety certification and help to move this technology forward.
So I suppose the benefits of a real-time operating system like PikeOS can come into play here and at least reduce the complexity of part of these systems. So great. Thank you for your insight. It's been a really interesting deep dive into your understanding of agriculture, eVTOL, and also DO178C as a safety standard and how this may be applied to these industries and these technologies in the future. So thank you for your time, Stanislav, and looking forward to discussing more topics with you in the future.
Yeah, Joel, thank you very much. It was nice to talk to you, and see you in the future as well.